Hello again, guys. This is Mr. Crawford. Today I am discussing Integrated Math 3's Practice 5, where we're talking about quadratic and cubic binomials. Binomials being something like x plus 6, for example, or a host of other things. These little guys are very powerful in figuring out what the graph of quadratic and cubic polynomials looks like, so we're going to look at them in more detail. First up, I just want to remind everybody what quadratic functions and graphs look like. If you have x to the second power in your equation, there could be other numbers around here, but x to the second power, you have a quadratic function. If you were to graph the points, it would make a shape known as a parabola. That's if it's positive, but if it's negative, it still makes a parabola, it's just upside down, like so. One step up after quadratic functions are cubic functions. Cubic functions occur whenever you have x to the third power. Again, there could be other numbers and things out here with it, but as long as you got x to the third, you're going to create a graph that looks like this, if it's positive. If it is negative, however, it looks the same, it's just going the opposite direction. So what is so important about these little binomials? Well, binomials help us identify solutions, or in this case, the x-intercepts. What we're finding when we solve these are where the graph will be hitting the x-axis. That's what x-intercept means. So let's take a look at this one, for example. This function says f of x equals x plus 4 times x plus 1. This is known as factored form. It has been factored for us. But because there are two binomials, this one and this one, I know this is quadratic, power of 2. And the solutions are the opposite of what they are inside the parentheses.
Could you please report to the auditorium, Mr. Kennedy? Thank you.
I guess you can see I'm still at school. What we want to do is figure out the opposite of each one of these to find the solution. So if x plus 4 is in the parentheses, the solution to that is x equals negative 4, the opposite. The reason being is because technically what happens is this gets put equal to 0 and then solved. And to solve this equation for x, you'd have to minus 4 from both sides. And 0 minus 4 just turns out to be negative 4. So it's the opposite of what it is in here, as long as the binomial starts with just x. So x equals negative 4 is one of the two solutions, right? 2. X equals negative 1 will be the other one. Except this is also a quadratic because it has two binomials. The opposite of x minus 2 would be x equals positive 2. Opposite of this one, x equals negative 3. The next two here are not quadratic anymore because there's no longer just 1, 2 binomials. There is 1, 2, 3 binomials. 3. So this is now cubic, power of 3. Right? The opposite of x plus 5, we would find x equals negative 5. X equals positive 1, and x equals positive 4. So if you visualize that, what that really means is if you were looking at a graph, there would be an x-intercept out here at negative 5, an x-intercept at positive 1, and an x-intercept at positive 4. Like so. So it's probably doing something like this. It's giving it that shape that we know that comes along with cubic graphs, what I like to call the snake shape, right? One end down, one end up. The solutions for the last one here, get it up there, would be positive 1, negative 3. And the last one's kind of interesting because it's 2x plus 1, not starting with just x. If that's the case, if you notice it doesn't start with just an x like these do, don't just put the opposite of that number. That's not the right answer. Go ahead and set this one equal to 0 and then solve. I'd have to minus 1. 2x equals negative 1. Then I would have to divide by 2. And negative 1 divided by 2 is negative 1/2 or negative 0.5. So that's what I'm going to write here for my third solution. Okay, great. We also need to know how to multiply these binomials in order to come up with the entire equation. Once again, this is two binomials, so this is quadratic, or 2. And if you're not sure how these work, or if you think you need some more practice, feel free to pause this video at any time, but I'm going to go through this relatively quick since this is kind of older stuff. But it works like this. X goes into the second parentheses and multiplies both of the terms in there. So x multiplies x and gives me x squared. X multiplies negative 4 and gives me negative 4x. Positive 3 now has to go do the same thing. Positive 3 times x is positive 3x. Positive 3 times negative 4 is negative 12. The two terms in the middle are like terms, so I'm going to combine them. I end up with x squared minus 1x, or just minus x, minus 12. So there's the entire quadratic, x squared, right? Quadratic, x squared equation for these two binomials. The next one, by the time you're done, you'll end up with x squared plus 2x minus 4. The two in the middle are going to cancel each other out. You get x squared minus 4. When you have 3, it's a little bit more difficult because you have to multiply the first two, get an answer, and then multiply the third one. When you multiply the first two, you end up with x squared plus 6x plus 8. And then you drop down the third binomial, and now this new trinomial that we got has to go into the parentheses and multiply each term. So if you can follow me here, x squared times x is x to the third. X squared times the 3 is 3x squared. Now it's 6x's turn to go into the parentheses and multiply both. 6x times x is 6x squared. 6x times positive 3 is positive 18x. Finally, positive 8 is going to have to go into the parentheses. 8 times x is a positive 8x, and 8 times 3 is a positive 24. We end up with x to the third plus 9x squared plus 26x plus 24 after we combine like terms. See, these two make 9, these two make the 26 because they're like terms. There we have it. All right. I'm going to skip this one and let you try it on your own. If you struggle with it, just try asking in class and maybe I'll go through it with you there, okay? Down here is where all this work comes into play, because what I need to be able to do is show you a graph of either a quadratic function, which are parabolas, right? They make this shape when it's a power of 2, or a cubic function when it's the power of 3, and see if you can generate the entire equation just based on what you see. So take this first one. This guy has two x-intercepts. You can't see them very well. That's located at -1 and +3. Well, since the solutions are always the opposite of what they are in the binomial, we can take that same concept and apply it here. If the solution was -1, then the binomial that made it must have been x plus 1. If the solution was +3, the binomial that made it must have been x minus 3. And now I'm going to multiply, just like I did up here before. X times x is x squared. X times -3 is -3x. 1 times x is 1x. 1 times -3 is -3. Two terms in the middle are like terms. If you combine them, you'll get -2x. So we end up with x squared, -2x, and -3. I'm going to stick an f of x equals in front of it, and now I have the entire equation of that line, or that parabola, excuse me, like so. Notice that the second one, there's two things I want to point out. One is that unlike this one, it doesn't hit the x-axis twice, it hits it one time. We refer to this as the bounce. When a graph is moving, when it approaches the x-axis, it has a choice. It can push through the x-axis as if it's breaking through a wall and keep going, right, like this one does. Or it may be moving, and when it hits the x-axis, it bounces, right? It doesn't break through and come back around and down, right? But instead bounces as if it hit a really hard ceiling. When this happens, when you have a bounce, that means this solution is actually there twice. That solution is x equals 3. The binomial that made it must have been x minus 3, the opposite. But because it bounced off of it, that must be there twice, like so. So now we can multiply it like we did before, and when you're done, you end up with x squared minus 6x plus 9. But there's one more thing to consider, and that is Positive quadratic functions open upward, negative quadratic functions open downward. And I noticed that this guy actually opens downward. So this really needs to be negative. What I'm going to do then is I'm going to multiply by -1 and change that. So I get negative x squared plus 6x and then -9. And I'll stick a y equals in front of that for now. So next one is a cubic. It has 3 x-intercepts. That is located at -2, -1, and +1. Right? The binomials that must have made that would have been x plus 2, x plus 1, and x minus 1. So if we were to multiply this whole thing, we get x squared plus 3x plus 2 when we do these two. Bring this one down, do this again, x cubed minus x squared plus 3x squared minus 3x plus 2x minus 2, like terms. Right. So I end up with x to the third power plus 2x squared minus 1x and minus 2. And I'm going to stick a y equals in front of that so that I have the entire equation. So those can get kind of long at times, but keep in mind, just bear with it one step at a time and you got it. Notice that on this one, it only has 2 x-intercepts, but it really looks like a cubic function, right? Looks like that snake shape. Why only 2 x-intercepts? Because this first one over here on the left, it doesn't cut through it, it bounces, right? There's that bounce again. It bounces as if a basketball off the ground. This one it cuts through and goes on down. But this bounce indicates that this solution is actually here twice. So that solution, which is -1, will actually give me x plus 1, but because it bounced off of it, I need it twice. And then finally, the other one would be x minus 2, because the solution is +2. If you end up going through all that, you'll end up with the entire equation, and I'll let you guys try that on your own. All right, tune in for part 2 and see the backside.